Good morning, welcome to the Lionhearted Academy. This is Richard Tai. We're continuing our trigonometry lesson. Today is lesson number 32, which is part 11 of our graphs on trigonometry functions. I believe I made a mistake just to correct that. The last lesson 31 was part 10, and so today is part 11 of the graphs, and I think we're about to be finished about talking about graphs on trigonometry functions. So we have covered the graphs of sine, cosine, and tangent functions, and it is important to talk about the graphs of the rest of the functions as well, which are the graphs of the reciprocal functions. So for example, the graphs of secant, the graphs of cosecant, and graphs of cotangent all can be discussed in the context of their reciprocal functions. Secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So let's go ahead and take a look at how do we graph secant in terms of reciprocal functions. How do we can use cosine to help us. Okay, so for example, let's go ahead and say we have a function in secant. Let's do 2 secant 3x minus pi. Okay, 3x minus pi. Let's just use this for now. So this is the reciprocal. Okay, this is the reciprocal of another function. Okay, a cosine function. So let this be reciprocal of gx, and so let's go ahead and write g of x. Gx is going to be 2 cosine of 3x minus pi. Okay. So, because we know secant and cosecant are reciprocal, so what we can do is we can graph the cosine first. We know how to sketch cosine. Once we sketch a cosine, then we can sketch the secant based on the cosine. Now, so the amplitude here is going to be 2. Okay, it's the absolute value of a, and the period is going to be 2 pi over b. So it's 2 pi over 3. B is the coefficient of x, and the phase shift it's going to be c over b, which is pi over 3, and the end of the period is going to be c over b, which is pi over 3 plus 2 pi over 3. Now, if you don't remember how do I do this, you can go back to review the previous videos. On lesson 30, I believe it's lesson 30, we did sine and cosine. So pi over 3 plus pi over 3 plus 2 pi over 3 is going to be pi. So our phase shifts, we're going to start with we're going to start with pi over 3. We're going to end our first period at pi. Okay. All right. So let's go ahead, and we have no vertical shift, so everything's going to be based on 0. The midline is going to be start from 0, and then we're going to go up 2 units. So 1, 2, 3, 4. I'm going to mark it a little bit more. So this is 2 units. 1, 2, 3, 4, -4. Okay. Alright, so that's -2 here. Alright, so let's see, cosine. Alright, and I'm going to start with pi over 3. So let me go ahead and mark pi. Okay, and let me mark 2 pi here. I want to give myself enough space so I can mark pi over 3. So this is pi over 3. Okay, alright, so I'm going to mark. Okay, we're going to divide into thirds, 1/3. Alright, so our period is going to start with pi over 3 and it's going to end at pi. So we're going to divide that into 4 parts. So this is 2 pi over 3, and this is going to be 1, 2, 3. 3 pi over 6 is going to be pi over 2. Okay. And this part, let me see, it's going to be halfway between 2 pi over 3 and pi. So that's going to be 1, 2. That means when you divide further into pi over 3 into halves, it's going to be counted by pi over 6. So that's going to be 5 pi over 6. So 1, 2, 3, 4, 5 pi over 6. Okay. All right. Now, at a sine, cosine starts with positive like this, and goes down like this, and go to the minimum at 2 pi over 3 halfway. Okay, let me go ahead and write it a little smaller. So -2 here, and then come back up and do it like this. So that will be one period of my cosine. Now, of course, I'm not graphing cosine. Okay, I'm graphing secant. So let me use a yellow line. Okay, actually, let me go ahead. Oh, let me not do that. I think that will utterly destroy. So let me go ahead and do a yellow line, a cosine here. Now I know this will keep going like this. No, I'm sorry. Halfway through it's going to go down here, a quarter way, or quarter and 3/4 way is going to go back to midline, and then it will come back here. So I know it's a little bit hard. It may be a little bit hard to see, but cosine. Remember, this is the reciprocal function here. All right. Now, how about in the middle here? Well, let me go ahead and mark negative pi over 3. Okay, and then negative pi. So from pi over 3 to negative pi over 3, it's also going to complete one cycle. So let me go ahead and sketch that for you. So we will follow the pattern, but we'll follow the pattern backwards. So we'll go down here, and go down, come back up, and then come back up like this. Okay, and then we'll keep going. Alright, so based on this, how do I graph the secant? Because we really want to graph is f of x, the secant function. Now, the secant function is the reciprocal function of cosine. So as you can see, when it will meet, it will be basically everything that's opposite to, kind of like opposite in a sense, to the cosine function. And whenever cosine function equal to 0, there's going to be an asymptote, a vertical asymptote. So the first thing I want to do is start from drawing some vertical asymptotes, okay, through when cosine equal to 0. This will be my divisions. Okay, whenever cosine equal to 0, I will have vertical asymptotes. Alright, so there are several vertical asymptotes I can see. Whenever cosine equal to 0, I have a vertical asymptote, because that's what happens when you divide by 0, right? Now, so now I can see, okay, at pi over 3, I am going to have a U-shape, kind of like a parabola, but not exactly. It's a U-shaped sinusoidal, a U-shaped graph that looks like this. It will approach infinity on as the curve of the graph approaches this asymptote. But then it will meet right here at 2 at pi over 3 2. Same thing here at 2 pi over 3. It will peak at 2 pi negative 2, but it will have a U-graph, kind of like a opposite parabola, if you remember parabolas. So the only thing I can say is kind of like a parabola here. Alright, so basically this pattern will continue. Okay, and then now we can just go ahead and sketch it like this. So the key is that the minimum of the sine and cosine matches the maximum of the cosine and secant and cosecant. So they meet right over there at 2. Okay, so it will go up like this. Alright, they meet at that minimum point, because at that point they have the same value, but otherwise they don't share any other value at all. And of course cosine has no asymptote, but secant has asymptotes. And so this is just a quick sketch of a secant graph. So as you can see, if you understand how to graph cosine and sine, once we graph cosine, we can graph secants very easily. It's going to be the same thing for cosecant. So let's go ahead and try an example for that. Alright, so let's take a look at this function. F of x equal to negative 3 cosecant 4 pi x plus 2 pi. Now, let's go ahead and write the reciprocal function first. So g of x, let g of x be equal to 1 over f of x. Okay, that means g of x is going to be negative 3 sine 4 pi x plus 2 pi. Okay, now so again, let's go ahead and start from g of x that we're going to be determining the amplitude. So of course amplitude here is the absolute value of negative 3. It's going to be 3, and the period is going to be 2 pi over b, which is 4 pi, so that would be 1/2. So the period is going to be 1/2. Now the phase shift, okay, so let's go ahead and put it over here. So let me skip this, move that a little bit. The phase shift is going to be c over b, so c over b is going to be negative 2 pi over 4 pi. So as you can see here, c is negative 2 pi rather than positive 2 pi, okay, because the formula was bx minus c, so this number is the opposite of what c is, so this is negative 1/2. So that means we start with negative 1/2, and so where does our first period end? Ending of the period here. So when we do ending of the period, it's going to be c over b plus 2 pi over b. Okay, so basically it's the phase shift plus the period. So it will be 0, okay, because we start with negative 1/2 and plus 1/2, so it's equal to 0. So that means, okay, so I'm gonna mark, I guess I can mark 1, 2, okay, I'm gonna just mark a little bit, and the unit's gonna be here, we're gonna be on the y or order pair. On the y-axis, I probably need more room here. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Alright, so I'm going to try to make a little more room on the y side. Alright, and 1, 1. So this is that's negative. That's positive 1/2. And so this is negative 1/2. Alright, so our first period is going to start from negative 1/2 and then end at 0, I think. Yeah. Right, that's end at 0. And we have no vertical shifts, so I'm not doing any vertical shifts in this example right now. Alright, so let's go and graph our sine first. Okay, so where would our sine be? Alright, from our first period, from negative 1/2 to 0, we're going to cut into what, 4 equal intervals again. So this is 1/4, that will be 1/3, this will be negative 1/8. So remember, sine starts with the positive. Start with 0 and goes up to the positive, but here our leading coefficient is negative, so you should go down to negative 3 here, then come back to 0 and then go up to 3, then we can end out here with 0. Okay, so it's going to be going down. Oh, I shouldn't use blue, I would like to use yellow here, so because this is not the graph that we actually want, right? This is not the graph that we actually want. This is just to help us, actually this is just to help us graph our secant graph, okay? Alright, so we're going to cut this into a quarter, 3/4, okay? Alright, so the pattern continues for sine. This will go down to negative 3, come back up, go up, and come back down. So minimum, midline here, go, and the pattern will continue. The pattern will continue here. Alright, so this keeps going, but again, to graph cosecant, we are going to do this. We're going to have to put an asymptote whenever sine equals to 0. So this is going to be an important part for our graph here. Cosecant will equal to 0, will equal to undefined when sine equal to 0. So that's why we're graphing this asymptotes here. Alright, so now we have our asymptotes done, then we can now graph our cosecant. Cosecant graph is going to be the same thing. If it's going to follow, it's going to look like secant, what we have done before, and it's going to look like u and negative u, upside down u, and right side up u, and then you will follows the asymptote, you will onto infinity. So as the graph approaches the asymptote, you will approach infinity. It will approach infinity. Okay. Oops. But you will never touch the asymptote. So there's a lot of there's a limit concept here involved. Later on when we get the calculus, but this is basically what the graph looks like. Okay, I'm sorry the sketch is a little bit rough, but I think you can understand. Once we graph the sine function, we can go ahead and graph its reciprocal function. Now what about cotangent? Okay, well, let's go ahead and take a look at cotangent. Alright, let me scroll up here. Let's do a very simple cotangent, 3x. Okay. Alright, so cotangent function follows the tangent function, but it follows in an opposite direction. Okay, so what we want to do is we want to decide, we want to find the position of the asymptote. Of course, the period here, the period is going to be pi over b, which is pi over 3. Now, then we need to find the position of the asymptotes. In order to find the position of two vertical asymptotes, we use bx minus c equal to pi over 2. that's for tangent. For cotangent, we need to use bx minus c equal to 0 and bx minus c equal to pi. Okay, so that's the difference between tangent and cotangent, because they have a phase shift of 9 degrees also. So there's a half a difference. The reason is cotangent equals to 0 when sine equals to 0. So the asymptotes happens at sine when sine equals to 0, which is 0, and then multiple and then 0 plus pi plus 2 pi plus 3 pi and so on and so forth. Okay, so in this case our b is 3. Okay, our c is 0, so 3x will be equal to 0, or in 3x will be equal to pi. Okay, so x will of course be equal to 0, and x here will be equal to pi over 3. So that means from 0 to pi over 3 we have an asymptote. Okay, so that's good. So we're gonna go have a 0, and then up here is going to be pi over 3. So let's go ahead and mark pi over 3, and 2 pi over 3, and 3 pi over 3 is going to be pi. So I'm going to graph those 3 periods. Alright, so let's mark our asymptote. Our first asymptote is going to be at 0, and the next one is going to be pi over 3. Next one is going to be at 2 pi over 3. The next one is going to be at pi. Alright, so once we determine this, then it's going to be very simple, because at the middle, okay, because we have no vertical shifts, okay, so at the middle point it should always be equal to, it will pass through the midline, okay, which is 0 in this case. Now this is pi over 3, so we want to go ahead and find out exactly what the values are here at this point, 2 points. Okay, so this is half of pi over 3, this is a quarter of pi over 3, which is 4 pi. Hold on, let me see. It's going to be pi over 12. Okay, this is pi over 12, and this is, so this tick is pi over 12, as we said. Okay, because this in the middle one is pi over 6, is half of pi over 3. So usually we got to use our fractions. Okay, and so half of pi over 6 is pi over 12. So each tick here is pi over is 1 pi over 12. So this is 1 pi over 12, 2 pi over 12, 3 pi over 12. Okay, this is 3 pi over 12. Alright, so what we have to do, how do I find out the actual value here? We can go ahead and plug in. So let's do 2 cotangent of 3 pi over 12 and find out what that is. Well, the cotangent of 3 pi over 12, which is the same thing as pi over 4, you reduce that. Cotangent pi over 4 is 1, so this is equal to 2. So this will be equal to 2. Okay, let's mark that, 2. And then at 3 pi over 12, okay, let's plug in 3 pi over 12 and see what happens. So it's 3 times 3 pi over 12, which is 9 pi over 12. 9 pi over 12 can be reduced to 3 pi over 4. So 3 pi over 4 is in second quadrant. So cotangent in second quadrant is negative, so it's negative 2. Alright, negative 1 times 2 is negative 2. So it will be negative 2 down here. Now, so we know this graph will look like this. Okay, so it will be same thing here. Okay, for the second period. So it will be something like, okay, and same thing for same thing here for the last period here. Alright, so it's a rough sketch, I'm sorry, as it doesn't look too good, but this is what we can do by hand. We can get a good idea of how the function behaves, and what the period is, where the asymptotes are, and which direction does it go. So it approaches now positive infinity as it approaches 0, but it approaches negative infinity as it approaches pi over 3. But on this side, on the right hand side, it also approaches positive infinity, so the graph just keeps going. Okay, it would look something like this. Alright, so if you have any questions and comments, please go ahead and leave the questions and comments in the comment section below, and please remember to subscribe or recommend to your fellow students about this channel. We look forward to seeing you in the next part of the lessons. We should be able to finish about graphings and move on to trigonometry identities and the fundamental relations from here. Alright, hopefully see you in our future lessons. Thank you.